Hello guys, welcome to another tutorial episode on EMV. Please remember to give a thumbs up, subscribe, and leave comments or questions below. I will be talking about offline dynamic data authentication. My name is Derek Peng. The key points of this episode are similar to those of static data authentication: keys and certificate, retrieval of certificate authority public key, retrieval of issuer public key, except for additional points which differ, which is where I will emphasize on this video. So please make sure to watch my video on static data authentication before watching this. The link for SDA is displayed on this video. The additional points are retrieval of ICC public key, generate dynamic signature, verification of dynamic signature, and of course we're going to see a demo on a PSOC 6 with Embed OS. DDA authenticated dynamic signature generated by the EMV card. This prevents counterfeiting. The signature to be verified is generated by elements specified in the Dynamic Data Authentication Data Object List, in short DDAL, which is read from the card. I will also make a video on how elements are read from an EMV card. The encryption in DDA is very similar with that of SDA, but DDA requires an additional key pair of a private signature key stored in the card and a public verification key certified by the issuer and stored in the card as ICC public key certificate with tag 9F46 hex. DDA therefore uses a 3-layer public key certification scheme rather than 2 as in SDA. Each ICC public key is certified by its issuer, and the certification authority certifies the issuer public key. This implies that for the verification of an ICC signature, the terminal first needs to verify 2 certificates in order to retrieve and authenticate the ICC public key, which is then employed to verify the ICC's dynamic signature. This brings us to the first point, which is retrieval of the certificate authority public key. Now, if you haven't watched the video I made on static data authentication, please go and watch it. I have explained the retrieval certification authority public key there, so I will skip these slides. And also the retrieval of issuer public key, I've also explained it on the other video. Make sure you watch it. The retrieval of the ICC public key. Now remember, we have the ICC public key certificate stored in the EMV card, and we have to read it with a tag 9F46. Now, after reading the ICC public key certificate, we have to decrypt it, and decryption is with the algorithm RSA. And after decrypting, we get a data structure similar to that of the table as shown. And these tables are always very similar. They have a recovered data header, which has a constant value of 6A hex, the certificate format, which has a constant value of 04 that have to be checked, the recovered data trailer, and so on. And after that, we concatenate from the second to the 10th element. And after concatenation, we encode the concatenated data with the algorithm specified in the hash algorithm indicator, and which is mostly SHA-1. After encoding, we get a hash result of length 20 hex, and we have to compare the hash result with this hash result. And if that is correct, we can go ahead to generate our dynamic signature. The generation of the dynamic signature is also very easy. The EMV terminal issues an internal authenticate command, including elements specified in the DDAL, the Dynamic Data Authentication Object List. Now, after the terminal issues the internal authenticate, the EMV card responds with a digital signature generated with the private key of the EMV card, which I showed you in the other slides. And during the verification, we're going to use the ICC public key to verify this signature. And that takes us now to the verification of the dynamic signature. Now, the verification of this dynamic signature also uses RSA as algorithm. After we have the dynamic signature, we have to decrypt it. And decryption is by using the ICC public key, which we also read in the previous slides. After decrypting, we get a signed dynamic application data. The signed dynamic application data has the same structure as that of this table. Remember the header, the format, and the trailer, which always have to be checked. And then after that, we concatenate from this second right down to this one. The pattern is always from the second to the object before the hash result. So we concatenate it. After concatenation, we encode the concatenated data with the algorithm that is indicated in this hash algorithm indicator, and that is mostly SHA-1. And after the encoding, we get a hash result. We have to compare the hash results with that of this result, and if they are the same, that means dynamic data authentication was successful. Now, enough of the theory, let's go over to the demo. Okay, welcome to the demo session. Now, I have inserted my card and I have started debugging, and I let it run up to this function to do the offline data authentication. As you can see, I determine the crypto method, which is read from the card, and this card supports dynamic data authentication. As I told you in the other video, we're going to do the whole demo on this card. And first thing that we're going to look here is the slide again to get an overview of what we're supposed to do. We have to retrieve the certificate authority public key, retrieve the issuer public key, retrieve the ICC public key, generate the dynamic signature, verify the dynamic signature. And again, let me highlight some points here. It's very similar to that of SDA, and the only extra stuff here is this key pair, the private key and the public key of the ICC. Now remember, we have to certify, or the issuer certifies this public key and saves it in the ICC public key certificate in the card, and also further saves this private key here, which are extra verification key pair which are used for the DDA. This makes the DDA more secure than the SDA, because SDA doesn't have this 3-level certification or verification. The rest is very similar to the SDA. So check the explanation in the SDA video, so we don't take too much time in this one. So here, after the issuer certifies the ICC public key, it provides a public key here to the certification authority. The certification authority further certifies the public key to generate the issuer public key certificate, and then provides the public key here, which is what we're going to retrieve to decrypt the issuer public key certificate to get the issuer public key. And when we get the issuer public key, we have to decrypt the ICC public key certificate again to get the ICC public key, which after that we have to do an internal command to generate the signature, which we're going to verify using this ICC public key, because the signature is generated by the card using this private key here. Okay, let's go over to the debugger. Here we have the dynamic data authentication. If we step into it, here the first thing is to retrieve the issuer public key. Retrieval of the issuer public key also includes the retrieval of the certification authority public key here. And as I explained in the other video, retrieving the certification authority public key requires us to have the certification authority public key index, the registered ID, and then every terminal is supposed to save at least 6 of these keys of applications that it supports. So we're going to use it to read the certification authority public key, and this is it here. We read it using this public key index and so on. So if we step over, after we have the certification authority public key, the next thing is to get the issuer public key, and getting the issuer public key requires us to read the issuer public key certificate from the card with the tag 90 hex. And after we read it, we have to decrypt it at this point. So I'm just going to let it run to this point. Here we decrypt the issuer public key using the certification authority public key, and when we decrypt it, we're going to get a table that is similar to this one. So we're going to have these hex values of the recovered data header, the certificate format, and the recovered data trailer. So I'm going to show you these ones now in this video. So after decryption here, we get the issuer public key. Now this is the recovered data here that I initialize at this point. So at this point, once we initialize it, we can check this recovered data. Here we see the header here is 6A, the certificate format is 2, the trailer is BC. So these 3 fields are correct, and we can go ahead and do our concatenation from the certificate format right down to the public key, this one. And after we do the concatenation, we're going to encode it with the algorithm that is indicated in this hash algorithm indicator, and that is 1. In this case, it is the SHA-1. So here is where we check the fields, we check the trailer, we check the header, we check the certificate format. I'm just gonna step over because the checks are correct, and after, if they're correct, we do a concatenation from the second to the 10th element. And after the concatenation, there are some other checks that we need, or some values that we can add in the concatenation. These are optional values, for example, the public key remainder and so on. So if the public key remainder exists, we can also add it to the concatenated data. And then here we can also check the public key exponent length and so on. And if they exist, we can also add them to the concatenation. And then now we have to do the encoding here. If we check the hash algorithm indicator and it is the SHA-1, we encode it using the SHA-1 encoding. And after we encode it, these are just some free stuff to free memory. We do the calculation here to calculate the hashes, to compare the hashes. So now we have the calculated hash here and the hash of the recovered data. Remember, here we have the recovered data, and this is how the hash looks like. Now I have two structures, so these are unions. If you want to put them in words, you can see them here. The hashes, they are of length 20 hex. So here we have 5, each is 4 bytes. Now these ones are all displayed in decimal. I need to maybe the hex value here, you can see it here. So anyway, the hash values here are going to be compared with each other, and if they are equal, it means we can go ahead and generate we can go ahead and recover our ICC public key. So this is exactly what I wanted to show you. These are just some minor checks of some values that we can also check. This is the issuer ID. This is the expiry date, which is also checked. Check if the certificate is valid and so on. And then at the end, we get our public key, which we wanted to get. So I'm just gonna step through. This all succeeds. So after that, we have retrieved our issuer public key. Now we check if the result is okay, and if it's okay, we go ahead to retrieve our ICC public key. Now, retrieval of the ICC public key requires us to read the ICC public key certificate, which is of tag 9F46 hex. So we read it. So remember, I'm going to make a video on how we read all the data that we need. So I've already read them from my card, and they are saved in this record here, Apple Trans record. So what I do is, whenever I need a data object, I just give the tag, and then I call this function, and it's going to return the tag to me, which is a series of bytes. So I read this and I check if the length is 0. If the length is 0, it means that it doesn't exist, so I return an error. But in this case, it exists, so we don't return any error. This is also, we get the remainder, but in this case, I don't want to go deep into this. We just want to focus on the ICC public key certificate, which we're going to decrypt. So once we're done with that, we have to decrypt it at this point. Now remember, to decrypt the ICC public key certificate, we need the issuer public key, which we already decrypted from the previous function. And this is it, it's saved here. So we decrypt the ICC public key certificate now, and we get a data structure that is similar to, let me see, where is it? Come on. Oh, I can't really see my mouse. Okay, now there we go. So when we decrypt it, we have this structure, and it's very similar. We have the header, the format, and the trailer, and then after that we're going to concatenate it, and the same thing. Okay, good. Now we have, let me just show you the recovered data structure. We have the header, which is 6A. We have the certificate format, which is 4 at this point. We have the trailer and the other one, and the hashes. So we're going to concatenate from the certificate format right down to the public key, and then we encode it with the algorithm that is indicated in this hash algorithm indicator, and this is still SHA-1. And once we encode it, we compare the hashes. Same thing. So I'm just gonna let it run. We're not gonna go through all that. I'm gonna let it run to this point to see if it returns okay, and it returns EMV okay. So now we have retrieved our ICC public key. Now we're going to go ahead to generate our dynamic signature. Now, the generation of the dynamic signature, here we have the dynamic data authentication list, where they are specified which object we have to supply to this command, the internal authenticate. Here we build this according to our DDAL. Remember, we have to get the DDAL here to know the exact specified object. I'm going to show you this in another video. For now, I don't want to go deep into this to confuse you. I want to stay focused on the certification and all the encryption and decryption. So here, when I step, we read the 9F49. Let me see, 9F49, which one that is. That should be 9F49. Just search 9F49. That is the dynamic data authentication data object list. So we read it, and once we have read it, we build the dynamic data object here according to what is indicated inside of it. So here you can see it has a length. The length is 3, so it has 3 bytes, and then we can format that. And I don't want to go into it. We can check the array to see the bytes, but that should be in another video. So after we've built it, we execute our command here, the internal authenticate command, and once we send it, our card is going to reply in this RAPDU. So I'm just gonna put a breakpoint here and then run up to this point. Now we have our response, and our response is the dynamic signature that has been generated here in the body. If you have not watched my video on commands and response, please check it to know how that works too. So I'm not going to explain that now. Here we have 131 bytes of the signature. That is what we've generated. So now this is just some format of data depending on what was returned. If it's format 1 or format 2, we parse it accordingly and save it. So here I save it in the dynamic signature. And now we're going to the next point, which is to verify the dynamic signature. The verification of the dynamic signature, remember the dynamic signature was generated using the private key that was stored in the ICC card. And now we need the ICC public key to verify the signature. Now jumping into the verification function of the dynamic signature, what we do here is according to the specification. So if you also have the specification, it's always nice to look into it. Here's the dynamic signature verification. We have points. We have to check the length of the public key modulus with the length of the signature, and if it's correct, we have to decrypt the data object using RSA to get this table, as I showed you on the slides. And then we're going to check these fields that you know in most of the data structure, the header, the trailer, the format, and if it's correct, we concatenate from the second to the pet pattern. And for this dynamic signature verification, we also have to add additionally the data element specified in the DDAL. So this is what we do here. We check the length with the dynamic signature with that of the ICC public key modulus, and they are correct. And then now we decrypt the dynamic signature, and once we've decrypted it, we can step here to get our recovered data. This is our recovered data that we initialize here. We have the header, we have the format, we have the trailer, and then now we're going to concatenate from the format right down to the pet pattern. And then additionally, we're going to also add the DDAL that is specified in the DDAL, the elements that are specified in the DDAL at the end of the concatenation. So that is what we build here. We first build the DDAL here, and after building it, I don't want to explain what is required in the DDAL. I'm going to make another video of that. We go ahead now to do our concatenation. We concatenate everything, and then we encode now according to the algorithm that is indicated in the hash algorithm indicator. And this is, if it's SHA-1, we encode with the SHA-1 encoding function, and after that we compare the hashes, and if the hashes are correct, it means DDA was successful. And then it return, we check if it returns us the EMV okay, and if it's okay, we free our object list that we've used, and then that's it. We set the crypto state. So this is the whole tutorial. It's taken a very long time, more than 20 minutes. I hope it's not boring to you, but I really needed to show you all this. I'll also make a video on combined dynamic data authentication. This is similar to DDA, so I'm not gonna have to explain too much, but take really good note of this. This is very important. This is the key of EMV transaction. Thank you very much. Make sure to give me thumbs up, subscribe. I'm also gonna make more videos to help you understand more and more. I've been receiving your emails. Sorry if I've not replied to you. No, it's work. It's not easy. I'm also doing something else, so but of course I'm gonna reply to you. If I've really forgotten, please remind me, send me another email, and I'm gonna let you know. But I will also appreciate if you put your comments below the video so others can also gain from them with the response that I'm going to write. Thank you very much. Bye bye.